Okay, so let's have a look at question one. Company sells a large pump pack contains a sunscreen, random sample of 100. Is taken, the pump mechanism of each container is tested by pumping at once. The total volume, so the total volume of the sunscreen that we got from the 100 containers is 2150 mils with a variance of 4 mils per container. Okay, so we've got two different measurements there. Assume the variance obtained from the sample is sufficient accurate estimate of the population variance. Calculate 95% confidence interval. So to get our confidence interval for 95%, use an integer multiple of z. So we're going to use plus or minus 2 standard deviations. So we need a mean and a standard deviation. So the total that we dispensed was 2150 over 100 pumps. So the average per pump, if you like, was 21.5 mils. My variance was 4. We've got a sample of 100. So the variance of my sample, the standard deviation of my sample is 2 over root n, which is 2 over the square root of 100, 2 over 10, which is 1 over 5. So I need a 95% confidence interval, so it's 2 standard deviations plus or minus. So plus 2 minus 2 gives me 21.1 to 21.9, okay? All right, so we've got mussel farmed in a bay, are normally distributed with a variance of 9. The mussels are sold locally in bags of 100. One such bag has a mass of 2,400 grams. Use this information together with an integer multiple to calculate a 95% confidence interval. Okay, so again, if the bag weighs 2,400 grams by 100 mussels, each one is about 24 grams. So the standard deviation of each mussel is 3 over the square root of 100, which is 3/10. So same sort of thing. It's sigma plus, minus 2 standard deviations, sigma plus 2 standard deviations, which gives me my interval. All right. What have we got here? This one looks more, it could still be tech-free. Company produces small muffins and large muffins. All right. The weight of the small muffins is normally distributed with a mean of 108 and a standard deviation of 2. The weight of the large muffin is twice the weight of the small muffin. Okay, so find the mean and standard deviation of the weights of the large muffin. So the weight of the large muffin is twice the weight of the small muffin. So it's 2 times E of S, which is 216 grams. So the variance of the large muffin is the variance of 2 times S, which is 4 times the variance of S, which in this case is 16. So it's got a standard deviation of 4 grams. So my large muffin has a standard deviation of 4 and a mean of 216. Small muffins are sold to retailers in boxes of 25. Find the mean and standard deviation of the weight of a box of small muffins. Okay, that the packaging and the weight is negligible. So the small muffins, 25 by 108, gives me a mean weight of 2,700. Okay, and so when we come to the variance again, it's easy to make the mistake of thinking we've just got 25 S's. Okay, and we have, but let's take that 25. It's not 25 times S, it's S plus S plus S plus S. We're getting a different muffin each time. We're not getting the same muffin 25 times. So the variance of 25 different S's is 25 times the variance of a single S, which is 25 times 2 squared, which is 100, which gives me a standard deviation of 10. Okay, so then the last part of the question. So find the probability that a randomly selected box containing 25 small muffins will weigh less than 2,680 grams. Give your answer correct. So we know that the weight of a box of muffins is now normally distributed with a mean of 2,700 and a standard deviation of 10. Okay. So the probability that X is less than 2,680 is, if you think it through, 2 standard deviations below. So if we're going to be 2 standard deviations below, that puts us about, that's my 95% confidence interval, or I'll go about 2.5%, which on the CAS gives me 0.0228. All right. Let's go to these few multiple choice. The weights for population of seabirds known normally distributed, mean mass of 5.2, standard deviation 0.4, 7 of the birds random. So we've got a mean of 5.2, standard deviation is going to be 0.4 over the sample size, which is 7. So the probability of the average weight is less than 5, negative infinity of 5, 5.2, 0.4, etc. We get 0.0929. So hopefully once you get the key parameters, we're right to go. Standard deviation for the battery life in hours of a particular brand of a power tool is 15 hours. 95% confidence interval for the mean battery life in hours of this brand is 68 to 72.3. Okay, the number of power tools that we used in this sample to get this interval. Okay, so we've told that the standard deviation is 15. The mean, or the middle, if you like, of my confidence interval is 70.2, which makes the error 2.1. Okay, 2.1 above, 2.1 below. So if I want to find the sample size n to come up with the confidence interval of an error of 2.1, 1.96 by sigma on m all squared, and we'll end up with 196, okay, which is D. We've got 2 towns with annual rainfall, Auburn and Beachtown. It's both normally distributed. The means are given respectively at 3, 10 and 10, and 640 and 25. Okay, the annual rainfall in Auburn is independent. In a randomly chosen year, the probability that Beachtown will have more than double the annual rainfall, okay, of Auburn. So what are we saying? We're saying that we want the probability that twice Auburn is less than Beachtown. So instead of thinking it like that, we're going to have to think of it as a difference. So we want the probability that 2A minus B is going to be less than 0. And now we've got to find the mean and the standard deviation of that linear combination. So as we've got here, if y is equal to 2a of minus b, the expected value of y is 2a minus b, which is negative 20. The variance of that distribution is equal to the variance of 2a plus the variance of b. Yeah. So the variance of 2a, 2 comes out the front to give me 4 times the variance of a, which is 4 times 10 squared plus 25 squared. So the variance is 1,025. So the standard deviation is going to be the square root of that. So now all of a sudden, I want the probability that y is less than 0 for a mean of negative 20 and a standard deviation of root 1025. So if I put that into the CAS, I get 0.7339. Okay, I think it's just as a little aside. If you think about the difference here with our variance of 2a, okay, as opposed to the muffin question previously where we had 25 muffins repeated, in this the statement here, this is a 2a, bring the 2 out and we square it because we're actually doubling, okay, we're doubling the result from the Auburn rainfall. So if we double the result of the Auburn rainfall, that's the impact we have on the variance, okay? Whereas the difference between that and having 2 different towns called Auburn or 2 different towns with the same mean and standard deviation, we've just got 2 lots of them, and so the 2 can come out there. We're not doubling one town. We've just got a number of towns with the same result, which is why with the muffins, we can take that 25 out without squaring it. But with my Auburn rainfall, we have to square it.